Welcome to Python Tuples. Today we'll talk about tuples, packing and unpacking them, accessing, slicing, deleting and reassigning them, tuple functions, methods and operations. We'll see how to iterate on a tuple and also nest them. You know lists. Tuples are like lists but immutable. A tuple is a collection of items that may be different. This is a tuple with 3 integers, and this one holds an integer, a float, and a string. We can also create a tuple with just one item. This is an integer, not a tuple. This is a tuple, and even this is a tuple. So it seems you need to put a comma after the only element in a tuple. Parentheses don't matter. Packing a tuple means creating it differently using a sequence of values. This is a tuple B with 3 values and there are no parentheses. Unpacking it means using a tuple's values to assign values to individual variables. This is tuple percentages. We store these 6 values in the variables A to F. Now C has the value 90. Let's learn to access values from tuples. To access an entire tuple, simply print it. And to access a single item from a tuple, we can index it. This is 95, not 90, because indexing begins at 0. But sometimes we may only want parts of a tuple, not the entire thing. We can use slicing to do this. Positive indices mean traversing left to right. This is the tuple and the indices are 0 to 5. Slice 2 to 4. This is values 90 and 89. And this is indices 2 and 3. 3 because 4 minus 1 is 3. Slice up to index 4. 99, 95, 90 and 89. Indices 0 to 3. Slice 4 to the end. 93 and 96. Indices 4 and 5. Slice 2 to 2 gives us an empty tuple because this doesn't span any index. 2 to 1 means nothing. 1 because 2 minus 1 is 1. Now let's do this with negative indices. This is the tuple and the indices minus 1 to minus 6. Slice up to index minus 2, 99, 95, 90 and 89. This is indices 0 to 3. This slice is for all elements up to the second last. And this one, 93 and 96. This is indices 4 and 5. And slice 2 to minus 2, 90 and 89. Because this is indices 2 and 3. Slice minus 2 to 2, an empty tuple. Because it cannot traverse from minus 2 to 2 left to right. And this one takes everything. Tuples are immutable, and so it isn't possible to delete parts of them. Delete the item at index 4, and it doesn't. Delete the slice 2 to 4, and it doesn't. But it is possible to delete an entire tuple. Delete percentages, and it no longer exists. Let's try reassigning tuples. This is my tuple. Can we change the value at index 3 to 6? No. Tuples are immutable and you cannot reassign items. But if a tuple holds a mutable item, like a list, it is possible to alter that item or list. My tuple 30 is 6. See, this does work. We could change the value 4 to 5 in the list in this tuple. Python has some built-in functions you can call on tuples. Let's work on this tuple. The len function gives us the length of a tuple. This tuple is 4 items long. The list at index 3 counts as one item. Max returns the greatest value of them all. This is A. What is max of A? 5. We can also find the greatest from a tuple of strings. This is the string high with a small h because that has the highest ASCII value here compared to capital H. And it isn't possible to compare values of incompatible types like strings and integers. If you asked for the greatest value in this tuple, it would say it cannot compare them because we also have a list in here. Min returns the item with the lowest value. In the tuple A, this is 1. Sum returns the sum of all the elements in the tuple. Sum of all the elements in A is 17. And strings cannot be summed. Any returns true if even one item in the tuple has a Boolean value of true. Here the string 0 is true, but here the integer 0 is false. Every value is false, so false. And all returns true only if all values in the tuple are true. Here the empty string is false, so false. Sorted sorts a tuple and returns this without modifying the original tuple. If we sort A, this is what we get. The tuple function converts another type into a tuple. This list can be a tuple, so can this string, with each letter as one value. Even a set can be a tuple. 213 becomes 123. Besides functions, we also have some methods we can call on tuples. Index returns the index of the first occurrence of an item in a tuple. This is the tuple. It finds the item 2 first at index 1, so it returns that and does not know it's also there at indices 3 and 6. Count returns how many times a value appears in a tuple. How many times does it have 2? Thrice. And now some operations you can perform on tuples. The membership operators check whether a value exists in a tuple. Does the tuple formed using the string have the string A? No, it doesn't. And does it not have X? Yes, it doesn't. We can also concatenate two tuples. Logical operators like equal to and less than. Is this tuple greater than this one? No. This compares corresponding elements, and since 1 is not greater than 4, it stops and returns false. And these tuples are unequal because one has integers and the other has strings. Now identity operators, is and is not. Are these tuples the same? No. We can iterate on lists and we can iterate on tuples. This for loop prints each value in this tuple. And we can also nest tuples like we nest lists. This is a nested tuple. 5, 6 is a tuple inside a tuple inside a tuple. To access the value 6 from this, we use indices 1, 1 and 1. The value at index 1 in the tuple at index 1 in the tuple at index 1. And we have 6. Lists are mutable and tuples are not. Let's compare them.